Hello, and welcome to Calculus Lesson 26. Today we are going to learn many more definitions of the derivatives so that you don't have to do the full definition, or we're going to learn tricks to find the derivative so that you don't have to do the full definition of the derivative every time. So let's review the ones we should know. If we have x to a numerical power, just a number, and we take the derivative of that, that's n, x to the n minus 1. Then we studied what happens when you have a constant times a function and you take the derivative. Well, that's just the constant times the derivative of the function. Easy enough. Now, today we are going to add a few derivatives to our list. So I'll keep the running list going there and we'll just continue this way. The first one is going to be e to the x. Now, if I wanted the derivative of e to the x, I know what to do. I'm going to use the definition of the derivative, of course. Limit as h approaches 0 of e to the x plus h minus e to the x over h. Now, you look at that and you're like, and honestly, I look at a lot of these and I'm like, and so sometimes when you really can't figure out what to do, you have to plug it into your calculator. And so what I would encourage you to do is plug in for h equals a really small number, and then graph this function. What you're going to see is actually pretty cool. It looks exactly like e to the x. So in fact, the derivative of e to the x is itself. That's kind of weird, but that is true. So that's that. So I'll add it to our list of derivatives over here that you should know. Trigonometric identity quizzes, goodbye. Derivatives quizzes, hello. All right, the next one. We are going to do where was I? Got lost. We're going to do ln of x. You can actually do the same thing here. Plug it into your definition of the derivative. And we can solve. It's actually pretty fun. If you were to graph this with a very small number h, you would see that it actually turns out to be quite interesting. The derivative of ln of x is simply 1 over x. So add that to your equation sheet, as I will do right here. Bam. All right, so now you are responsible for knowing 4 definitions of the derivative, but we're not done yet. Now, let's go to our good old friends, sine and cosine. Notice that I put, actually I didn't, that's fine. Okay, so what is the definition or the derivative of sine and cosine? Well, if we look at the graph, we can kind of discern it. So let's graph a sine curve. And then I'll graph a cosine curve for you guys. So if this is sine, then cosine is something like this. Let's hope this works. All right, so what do we know about the sine and cosine curves? Well, again, when we're talking about derivatives, we're talking about the slope of the curve. So what's the slope at 0 of the sine curve? It actually turns out to be 1. If you want to check that and you don't believe me, you can actually find the derivative using your calculator at any given point on a graphed function. So it's in that calculate menu, the same place where you find your zeros and your intersect. There's a dy by dx option. Now, at pi over 2, sine is, or the derivative of sine is 0, right? It maxes out. On cosine, the value of this function is 1, and at pi over 2, the value of this function is 0. At pi, the slope of sine is -1, and at pi, cosine is -1. And so just by inspection, we can see that the derivative of sine is cosine. Now, fun fact, the derivative of cosine is negative sine of x. Do we like that? Well, if the slope is here, is 0, if I go to sine of x, the value of this function is 0. So we're good. If I go here, the slope is -1. The value of sine is 1 at that point, so we make it negative. The slope is 0 here, sine is 0. Slope is negative or positive 1 here, so we make it negative. So add these two to your equation sheet as well. Derivative of sine is cosine, and derivative of cosine is negative sine. I will add them to my equation sheet here. Alrighty, now the last thing and the last part of our lesson today is exponential growth and decay. This should be a review from pre-calculus. So what is the equation for exponential growth and decay? Well, up to this point, I've just given it to you and we've not proved it. And we will continue that trend until later this year when we can actually prove it out using calculus. So here is your function. The amount of whatever you have at time t, remember this is a function, is the amount at time 0. We use a naught to dignify that, or to delineate that, times e to the kt. If k is greater than 0, or k is greater than 1, then we have growth. Nope, definitely 0. And if k is less than 0, we have decay. If k equals 0, then we have the same amount forever, which is really boring. So let's do an example problem and we'll go from there. The amount of bacteria present at noon was 400. 9 hours later, the bacteria numbered 800. Assume exponential growth and find the equation that describes the number of bacteria as a function of time. Then find the number of bacteria present at noon the next day. So, how do I find the equation? Actually, pretty simple. What I'm going to do is I'm going to plug in these values here. So, I know that 800, if I were to write out my equation, AT equals A naught e to the KT. So, 800 is my initial amount, which we'll call 400, e to the K. We don't know K yet. K is going to be some constant that describes how fast or how slow this is growing or decaying. But I do know the amount of time. So, once I use the time in here, in this case in hours, I always have to use it in hours. Very important. How many hours was it between noon and 9? Well, it was 9. So I can solve this by dividing by 400. Then taking the ln of both sides. And you're going to have to plug and chug this into your calculator. We remember that ln of e to something is just that something. So I can divide by 9. So k is ln of 2 over 9, which is some number. I would encourage you to carry that number out to as many decimal places as you possibly can. Or just leave it like this when you go on to your next part of the problem so that, I lost my eraser again. Oh man. So that you are not losing any, or you're not including any rounding error. Especially on the AP exam, you want to leave everything as exact as you possibly can until the very end. So I'm going to leave k as like that. So when they ask what is the formula, I have to give the formula, and that should be part of my circled answer. So k is ln of 2 over 9 times time. So that is my formula. Now they want to know how much was present at noon the next day. Make sure you read the whole problem. Noon the next day would be 24 hours, so I can plug in 24. And that gives me a number of 2540. Make sure you round. If we're talking about number of things, you have to round to the ones place because you can't have half a bacterium. So that, my friends, is problem set 26.